Good day, everyone. In today's lesson, we are going to delve deep into contour representation, or contour lines for that matter. So contour lines plays a huge role on the plane and landforms that occur on Earth. So if you can check here, we have different kinds of landform that occurs that are regarding contour representation. So of course, today's lesson is going to be all about that. We are going to continue talking about contour representation. In this sense, we'll be talking about the fundamental concept of contour representations or importance of contour representation. So the first thing that we'll talk about with this subheading will be elevation, and then the second thing will be contour interval, lastly depression. Elevation represents point of equal elevation above sea level. So, for example, points. Let's listen to the definition. Points of equal elevation above sea level. So, if we consider this as a sea level, so elevation will mean that this contour line here, the first contour line, is going to be the point. The equal elevation above sea level, and this one, 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 and so forth. So that's how we elevate with contour lines, right? Now we will move to contour interval. Contour interval is the difference between contour line elevation. Like if you check here, we start from 300 meters, 250 meters, and then we go down to 200 meters, and then we go to 150. So if you check, there's a difference in contour interval. The numbers are different. That's what contour interval means. And then we'll go to depreciation. Depreciation, if we can use simple terms, is if on a plane there's a sudden sink of a plane length or a landform that will cause what we call depreciation, right? Now we will move to the following slide, which is a plane, flat plane. Everyone knows what a flat plane is. It's a flat area. It's not supposed to be steep, gentle, whatsoever. It's supposed to be plain. If we check on this model, there's a flat plane here. This is how you identify a flat plane. There's not much to talk about when it comes to flat plane. But what you need to know is how it forms, characteristics, and examples. Now, how does flat planes form? They often form by deposition of sediments, right? Deposition of sediments over a long period of time. The sediments can be carried by the river, wind, or glaciers. Now, that's how we form what we call flat planes or plains. Now, characteristics. What are the characteristics, right? Now, they are typically gentle slope, right? Or area of relevant flat slope. And these plains are generally found in low elevation, right? Low elevation meaning that areas that are not steep, because obviously are flat. It's a flat plane. Now we will move to examples. Examples will be Great Plains of North America and other examples. We won't talk much about that. We'll move to the second slide, which is the archway and water gaps. Of course, in simple lane terms will be natural passages. Now, if you look here, archway, if you can see, archway is this way or water gap, if you want to call that, this side. So what are archways, right? How are they formed? Of course, is the question that you might have. Water gaps are formed by the erosive power of the river and streams, right? So now, when the river is flowing, it's eroding a lot of substance or sediments within. Now, that's how we are forming what you call archways or water gaps, right? Now, the significance, what are the importance? Water gaps are often serve as natural pathway of transportation and trade route. What does that mean? It means that these aquae, they transport sediments because this is the pathway of the river. You understand? So now they transport sediments. We won't talk much about examples, but let's just have a glimpse of the example. There are Delaware water gap in the United States. Mara, of course, we've never been there, Mara. That's a good example. And then we'll move to cliffs. Vertical face of nature. This is a self-explanatory term, vertical face of the nature. So cliffs, they are vertical face of the nature, Mother Nature. Okay, so now let's talk about cliffs. The most important thing that you need to know with regards to cliff is erosion. In this case, weathering, tectonic activity, and location, right? Let's try to show you where the cliff is on this example. If you can look here, we have a cliff. It's located here. You can check. Now, how is this cliff? We talked about erosions. How are these cliffs eroded, and how are these cliffs weathered, and the tectonic events? How do they occur? Now, let's talk about erosion for a moment. Cliffs are often formed by erosion caused by waves, winds, and glaciers. What does that mean? When you see a mountain standing, there's a lot of activities that are going on that mountain. For example, wind. Wind is coming and is blowing. There are rocks that are very soft. Those rocks will erode. And there are also characteristics like glaciers. Glaciers refers to mostly ice. So now when you see ice, when ice holds on to something, or when it freezes, it expands, causing a rock to crack, meaning that it's eroded, right? We'll move then to weathering. But don't forget, all these characteristics we are talking about, they are leading to form a cliff. So erosion is part of that. Now we are going to weathering. Weathering, the breakdown of rocks by physical or chemical processes. What are physical processes that we are talking about in this case? Physical processes are the processes like what? Wind. When wind is going to a mountain and it hits a mountain, that's a physical process that is going to happen, erosion, right? Now, what is a chemical process that might happen? If a rock, if let's say okay, now because we talked about physical processes, now we're going to talk a bit about chemical processes. We won't focus more on that. But chemical processes, these are processes that happen inside the rock, changing the fundamental characteristics of the rock, right? The rock will formally change its characteristics because of these chemical processes that will erode. Now, let's move, because of time, let's move to waterfall, and then we'll conclude with spurs, mountain, and that valley. Okay, so let's talk about waterfall. One thing that is important with waterfalls is that with contour lines, waterfalls, the contour lines that represent waterfall, they are touching. That's the most important part about contour lines with regards to waterfall. They are touching, right? You can see here. Now, we will definitely be moving fast now because time is not on our side. We'll talk about spur, mountains, passages, passes, neck, and necks, right? Here is a neck, if you can see, and here's a mountain pass, right? We won't even dwell much. Go and study the characteristics and the descriptions and the formation about these characteristics. And lastly, we'll talk about valley and gorge, right? This is what will be your homework. Go check out what is valley and what is a gorge. We'll mark it on Monday next week. Thank you. Okay, what you need to take out from this lesson of today, the conclusion basically is that the most important things that you need to know is the definition of contour lines, the fundamental characteristic of contour lines. Of course, we talked about elevation, we talked about depreciation. You need to know all of that. You also need to know how to locate waterfall, spur, gorge. You also need to know the difference between the characteristics of a river valley and a gorge, and that will be it for today.